For number 5, we're looking at the relationship between a child's height and their head circumference. So you'll want to open the data in StatCrunch, and then in StatCrunch, you'll want to go to Stat, Regression, Simple Linear, and our X variable is the height, and we're seeing if that can be used to determine what a child's head circumference will be. And to come down to see the hypothesis test we're really going to be working on later in this problem is to see if there's evidence for a linear regression. So if there is a correlation, the slope between the x and the y variable will either be a positive slope for a positive correlation or a negative slope for a negative correlation. So our null hypothesis is that the slope is 0, there's no correlation, and our alternative will be that there is some slope on the best fit line, which means the correlation is either positive or negative. So when you hit compute, StatCrunch will give us the best fit line, and that's what we're asking for here to start the problem off. B sub 0 is the y-intercept of that best fit line, and B sub 1 is going to be the slope value for that best fit line. And then use technology to compute the standard error of the estimate. We're going to be able to get that right here at the top two. It's just listed right there. And so we're going to use technology to determine now the standard error of B sub 1, which remember that goes along with the slope. And so you would look down here in this first chart, and the standard error that goes along with slope listed right here, that's what you want. And then finally, we're going to get in and actually do the hypothesis test to see if there's evidence that there is a correlation that the slope of the line is not equal to 0. So that's how you want to set up your null and alternative. The null is that the slope is equal to 0, no correlation. The alternative is that it's not 0 and there is a correlation. And so that's what you're going to be looking at on the slope line. What's the p-value? That's testing that, and you get your probability value, and that is below alpha, like we always do with a hypothesis test. If it's below alpha, that means there is enough evidence to reject the null hypothesis. And so we can conclude that there is a correlation, a linear relation between a child's height and their head circumference. And then to finish off the problem, we're going to actually go back and do a confidence interval. And so we can go to Options, Edit, and then scroll down to where and switch it to confidence interval instead of hypothesis test. And make sure we have the right confidence level and hit compute. And here, for the slope is what we're looking at. So go to that chart there where it says slope, and you get the lower and the upper limit for our confidence interval. And so here we're just saying we have confidence that the slope is somewhere in between those two values. And so this backs up our previous method here with our hypothesis test. Because this interval does not contain 0, there's evidence that the slope here is actually a positive value somewhere within this range, and that these two variables, x and y, are correlated. So then for F, suppose a child has a given height. What would be a good guess for their head circumference? You're going to want to plug that height into the regression line equation, which you found the values for that at the beginning, and it's listed here as well, again, back in StatCrunch. So for this example, I'm plugging a 26.5 in there. And so here I'm just doing it in Excel as my calculator and plug that value in for x, and it gives you back the y value. That would be a good estimate, and which in this case would be the predicted head circumference for someone with that given height. Number 6 is pretty similar to number 5, so I'll go through it a little bit faster. We're trying to see if the 7-day strength of concrete is correlated with the 28th-day strength of that same concrete. So we're going to open this data here in StatCrunch, and then we'll want to go through the same steps here of stat, regression, simple linear, and our 7-day strength is being used to predict the 28-day strength. So the b sub 0 is the y-intercept. The b sub 1 is the slope of the regression line. So you'll see those at the top where the regression line is listed. The standard error of the estimate is listed right at the top as well. And then our standard error for b sub 1, which was the slope, go to that table, standard error and slope, where those intersect right here, that's listed right there. And then your null and alternative, the null is going to be that there's no slope. The alternative is that there is some slope. Maybe it's positive, maybe it's negative, but it's just not 0. And we can find the p-value for that by staying on that slope line here in the table and going over to the p-value. And since that is less than our alpha, that means we will reject the null hypothesis, which makes us conclude the alternative is true, which corresponds to there being a linear relationship between our two variables. And so then to do the confidence interval, you come back here and instead of having hypothesis test checked, you go to confidence interval, make sure you have the right level of confidence, and hit compute. And again, looking at the slope, you want to go over to the upper and lower bound there, so we can be confident that the slope of the regression line is between those values. And then if they give you a value for x, you plug it into that regression equation and you can get back the value for y, which is our estimated mean for that particular value of x. So plug that 3,000 into our regression equation, which again is listed at the top here. So showing that here quickly, 3,000 was the x value that we were plugging in. And when you put that into the regression equation, you get the estimated value for what y would be, which is the 28-day strength of the concrete for that corresponding 7-day strength that you plugged in. For number 7, we're looking at the relationship between a male's age and his HDL cholesterol, which is the so-called good cholesterol. So we want to open that data in StatCrunch, and part A was about looking at a scatter diagram. So go to graph and scatter plot. Our x, our explanatory, is going to be the person's age, and then the response variable is their cholesterol. So if we draw that scatter plot, do we see a linear pattern? You would look to see if you see one. In this particular case, it doesn't look like there's any sort of pattern, either positive or negative linear. It just kind of is a random scatter plot. So for something that looks like this, we'd say there does not appear to be a relation between these two variables. So we can still use our sample data here to see what a least squared regression equation would be for the sample data we have. So come in here, stat regression, simple linear. We're seeing if age can predict the cholesterol. When we hit compute, we get an equation for our least squared regression line. Part C is asking if there's any outliers, so you can look at the actual data to see if there's any outliers. You can also look back at the scatter plot and see if there's any points that are really far away from the rest of the data, and there really isn't anything here that would stand out as an outlier in this example. So for part D then, we're actually going to do the hypothesis test to see if there's evidence that there is a correlation or not. And so we're testing, our null is always that our slope for our regression line should be 0, which is evidence that there's no proof of a correlation, either positive or negative. And the alternative is that it's not equal to 0. And so we should already have our p-value calculated. Looking back at those same results where we got the equation of the regression line, we can go to the slope. We're seeing if there's evidence for the line having a slope that's not 0, and we get this p-value. Now that is larger than alpha. And anytime our p-value is larger than alpha, it means we do not have enough evidence to reject the null hypothesis. And so looking to see if we'll get that same result from a confidence interval, which we will, we would go to edit and just switch it to a confidence interval, make sure you have the right level of confidence. Hit compute, and again, look at slope, see what the lower and upper bounds would be for the confidence interval. And so since one of them is the lower bound's negative, the upper bound's positive, 0 is contained in that confidence interval. So again, that emphasizes that we don't have enough evidence to reject 0 as the slope of the regression line. And so then part F, kind of summing everything up, it's asking if someone visited the doctor, should the doctor use this least squared regression line, plug in the age for X, and get back the prediction for the HDL cholesterol. And since both of our methods here, the hypothesis test and the confidence interval, had the result that we should not reject the null hypothesis, that there is no evidence for a correlation here, we do not want to use the least squared regression line. And it kind of spells that out right here. If it was rejected, that means the least squared regression line cannot accurately predict the HDL cholesterol of a patient. So we would choose no because the null hypothesis was not rejected. And a good estimate then is just going to be the average of the Y values from our sample data. So you would take all of, I'll just do this quickly over here in Excel. I'm going to look at the average here of all the Y values for all the cholesterol levels. So select them, close the parentheses, and you get the average of all the Y values from our sample. And that's what you want to enter in as your estimate for the cholesterol levels of this patient or any patient, because we don't have a regression line to use to make our estimates. We just have to use the average from our sample.